everyone, welcome to this video where we are going over a graph of the tangent function with transformations. This might be one of the first times in an example you sort of have had the pi symbol, the pi value, used differently. So let's see what ends up happening. And if you got this right at the end, give yourself a high five, because a lot of people will be discouraged and not persevere just because something doesn't look familiar, and that's absolutely not a reason to not do something. That really separates those who will from those who won't. It doesn't matter those who can or cannot, it's will or won't, right? So let's get moving. First thing I'm going to do is I'm going to look at the fact that it's a tangent graph, and you need to know what is the appearance or the visual look of both the positive tangent parent function and the negative tangent parent function. So let's just do a little note for ourselves. So y equals tan x and y equals negative tan x. I know that you could tell yourself a million times that it's going to make a vertical reflection, but for some reason, that's not always enough, and you want to make sure you are actually picturing it. So we are going to worry about nine tick marks, right? That being 1, first, last, middle, that's 3, middle, that's 5, and middles again, that's 4 more to the 5, makes 9. Tangent, meditating man, starts with a 0, then we go 1, asymptote, -1, 0, 1, asymptote, -1, 0. I think I said everything out loud correctly, I hope. Practice doing this. Practice, drill yourself on knowing the parent functions and come up with your own strategy or technique to memorize those patterns, okay? 9 tick marks here. First, last, middle, and middle. We should know also, like, this is 2 pi. The ones and negative ones are the pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, so on and so forth. So 0 stays the same. So every other is a 0 or an asymptote. So I'm just going to put these points on differently. 0, asymptote, and a 0, 2 pi. However, instead of going up first, we're going to go down first. So that's going through at -1. Then that will be a +1. Maybe this time, actually, I continue drawing in these branches and put the 1 and -1 after, Oops, that's hard to say. So there we go. Okay. Now that we have that sketched out, I know that my graph should have this shape, so I'm going to kind of draw this blown up right over here, and then we'll fill in everything else like we usually do. What we did do differently is we put in our dashed sinusoidal axis through our middle of our graph, more or less, first, because it gives us somewhere to plot the zeros, okay? Gives us somewhere to plot those middle points. And, well, that's going to be at 5 pi. So this is sort of no big deal. Like, it's just really telling me that my y-axis could or will have pi on it, okay? And if it's an equation of a dashed line, the axis there, we put y equals in front. Next up, I'm going to acknowledge that negative pi. The negative is going to make the shape, and the pi is going to make that stretch. It's bigger than 1, 3.14, so it will stretch it. And negative tan, I'm going to put the shape on here, so I usually confirm that in yellow. So let's go do this. So we're going to have a 0. It's negative, so then we're going to have something there, then an asymptote. Well, actually, let me do my little strategy. So these are not really the tick marks. 2 ends, middle, and each of those middles. Okay, just so I know I fit all my stuff. So this is not the x-axis, right? But every other point is a 0 or an asymptote. A 0 or an asymptote. There we go. Then we're going down over here. So I'm going to actually draw my curve in, really not to scale if it's stretched, whatever. But I really like scooping it quite a bit because I feel like it really exaggerates that point of inflection at the 0 here, which I think is important that you get used to what a point of inflection is. What does it look like? It's a big topic in calculus. Okay, so where's this pi coming in? Right over here. That's how far these ones and negative ones, we like to look at the spot where it was up or down 1 because it's easiest to see a stretch or compression at that point because 1 times that number, right? So I'm going to go over here, and that means if it's negative pi, pi up, pi down, so that's going to be 4 pi and 6 pi that I'm worried about. Okay, 4 pi is the lower spot, 6 pi is the higher spot. That's not a max or a min like it was with the other graphs because there is no max or min in a graph that goes up and down forever, right? We don't even have a local max because it is always decreasing or increasing, and there's no change from increase to decrease or decrease to increase, so you can't ever hit even a local max or min. Important concept there. The next thing we usually do is we do the h, which is +6. So bunker house, backward house, +6 means, oh, I always do this. I could draw my x-axis. It's below. That's 4 pi. I mean, 1 pi, 2 pi, 3 pi, 4 pi, blah, blah, blah. So here's my x-axis. Then this tick mark, +6, it's -6. So the last thing I have to do, I'm going to put down these tick marks and figure out what to label them with. And then we're good to go. Not the best spacing, I apologize. Period. The period formula for tangent is pi over b. Remember when you're tan, it's summer, we're going to cut down on the pi, only 1 pi. So we're going to cut down on the pi. And this is not an asymptote, that's just my h value. So that's the b value, all right? So let's go over here. Period is pi over b. b equals pi over 8. Period equals pi over 8. Pi times 8 over pi, which is 8. So the period is the distance from the first to the last point. But, oh, I should be careful. That is the end of one period. And then we've been drawing 2. So that's the end of another period. Then we divided a period by 4 because look, 1, 2, 3, 4. And we just kept going till we did 2 of them. So we still want that quarter period. So I don't know why I write all this work squashed on the side. Quarter period is 1/4 of, what was it, 8? 1/4 of 8. Well, that's 2. Beautiful. So we're just going to keep adding 2. No common denominator needed. We have integers. Life is great. That means that's -4, -2, 0, ooh, my y-axis, 2, 4, 6, 8, and 10. I'm going to go right here and draw my y-axis. That means I can label this tick mark with 5 pi. Put a little tick mark right here, that's 4 pi. And this one, cutting right there, that's actually right at 6 pi. And looks pretty good. I guess I could just grab a marker. I don't remember what color I was making my asymptotes, where it was undefined. Does anyone remember? Too bad I don't have an audience right now to help me out. I'll just do this teal color. And I think we're good. Oh, I think I used teal a lot of the time for the quarter period, but all good, all good. And I guess I'll just use a red this time. So the quarter period was 2. So that means that this distance from there to there was 2 every single time. All right. The domain we're going to talk about in a separate video when we go over all domains. But if you are in a more accelerated class, then you should be talking about this already. And the range is going to be -infinity to infinity. If you got this right, amazing. You're great. Give yourself a high five. If you got this wrong, at least you tried. You get a gold star. If you didn't even try, step up. Okay? So let me know how you feel, how you did by a thumbs up, thumbs down. Need more help? Are you confused? Thumbs down for me. And if you feel better, pretty good, put a thumbs up, and I will see you next time. Have a great day.